All right, here we go. My name is Jacob Humphreys, and this is our software 3D project where we render 3D object files to the screen. Right here, we enter the app with our main method in the main.cpp file, where we instantiate an object loader, which is a custom object that we wrote. We load the app state, which was saved from the last time the app was opened, and we also grab the file manager paths, so that way we can load textures and backgrounds and 3D objects. The next step that we go to is creating a mesh with the object loader, and then we instantiate a GLFW window, which is a library that can create OS windows across your platform. Then we set up resources and we start our rendering loop, which will take us to the next part of our software. Right here is a bunch of GLFW calls from our library. This is taking in the window width, the window height, and it is using a bunch of methods to create this window that we see up here. Then we can go to our next section. This is setting up the resources. This is instantiating the graphics library. The GL methods that we see here take a C script for our shaders. We have a vertex shader that's custom, and we have a fragment shader. We use graphic library methods to move those custom shaders over to the GPU where they become actual objects. And then that's also where we can send our vertex object arrays. And here we can see several new types of objects that we use that get set up and plugged in right here in this part of the app. And this allows us to take 3D coordinate objects like our object files, iterate through them to create a mesh, and then that gets passed into the pipeline. Up next is Dakota.
Dakota, I guess your microphone is turned off.
God bless America. I'm so sorry. You can see the roadmap right in the comments. Build transforms, move vertices to screen space, rasterize, upload to GPU, draw UI, present. We also set up our runtime state here, the current mesh texture, background, and screen vertex buffers. Now for part 2 is once we have screen positions, we loop through triangles. If wireframe mode is on, we just draw the 3 edges of each triangle as lines, and otherwise we move on to filling them. Now, part 3, for fill triangles, we call draw triangle. Passing in the 3 screen positions, depths per vertex, light intensities, and optionally a texture. This is where Goran shading and texture mapping happens across every pixel the triangle covers. Now my last part is frame buffer CPP, and this is where each pixel actually gets written. Before we commit a color, we check is this fragment closer than what's already here. If not, we skip it. If yes, we update the depth buffer and we write RGBA bytes. This is depth testing, and it's what makes closer objects appear in front of farther ones. And that's the full pipeline math, turning triangles into final visible pixels. Moving on to the next speaker.
Yep, I'm Tristan Jones, and I'll be covering a couple more specific details in the graphic pipeline, starting with the objects. With the objects, we're going to be going through the objects line by line, looking for the vertices, or rather the vertex positions, the UV coordinates, along with the faces. And as we do so, we're going to be passing them along to the data loader, which essentially populates the mesh arrays. And then we're going to use a technique called fan triangulation, which takes those vertexes and transforms them into triangles that the rasterizer can handle and read. That goes into our next part, which is the texture, the texture function. And here, what we're doing is we're taking JPG images and we're mapping them to specific coordinates on the mesh. And as we do so, we're going to be passing that along in the graphic pipeline. That way the image is mapped to certain positions that can then be rendered by our next part, which is the rasterizer. Within the rasterizer, this is the heart. This is where we're going through all the different math libraries and coordinating the different triangles, and then We're going to start rasterizing them and converting them to an abstract 2D screen object that can then be handled by that frame buffer. With that, once that mesh is all set, it'll then be drawn onto the screen. And then in our main CPP, we also have UI interface that's dynamic, which allows the user to manipulate the light direction, how strong the ambient light is, along with a few other things that makes it more interactive and affects how the objects are rendered. And that leads us to our next part, which is covered by Eric.
Hi, my name is Eric, and I'll explain how the camera mode is working in our program. First of all, camera mode is a boolean that controls how user input is interpreted, either moving the camera or rotating the model. It's a toggle by pressing the X key, using a common technique where we track the previous key state. X was pressed to avoid multiple toggles while the key is held down. When the camera mode is true, the was key move the camera using process keyboard. When the camera mode is false, the same key state rotated model. This is done by computing rotation angles, manual road X and manual road Y. And then also we have the app state. The app state is this code implements a simple persistent system for application state. It allows saving the current UI and rendering the settings to a file, and then loading them back the next time the application runs. It works with two functions. The principal function is the save function that basically saves the old settings that the user set while he or she is using the app. And then the load function runs the latest settings using in the last session. It means then the user will close the app, and when they reopen the app, he or she will see the same settings that he or she set up in the latest session. And then we have the recent file manager. This class basically saves the 10 latest objects opened in the app. It's basically like a history or an historial that we can save the objects, and the user will have the option to play with them, rotate the objects. And basically, this is the recent files manager. Is a class to save the objects and the app state and the camera mode.